In Chapter 14, Exercise 6, they're asking you to write a balanced equation for the reaction of different carboxylic acids with NaOH. And one thing you'd want to see when you see that NaOH is that it is a base, right? If you remember from the Arrhenius definition, water is neutral. You can crack water open, break it apart, and you would get H plus and OH minus. Anything that can give an H plus is an acid, and anything that can give an OH minus is a base in this Arrhenius definition. That's the first definition of acids and bases. And since NaOH, if you put NaOH into a solution, you can break it up and get Na plus and OH minus. Because of this OH minus, this is a base. So we're taking a carboxylic acid, and just while we're on the topic, carboxylic acid is a carbon, double bonded to oxygen, single bonded to OH, and then some carbon chain. This H on the end is the H that all carboxylic acids can donate. They can throw that H plus away and then have the O minus, and that's what makes these an acid. So this is really a neutralization reaction, which is coming from an earlier section in the course. And in a neutralization reaction, you always have an acid plus a base, gives you a salt and water. Now a salt, remember, is any ionic compound, so that's any metal plus a nonmetal. That's a salt. And that's the general form for a neutralization reaction. Okay, so now let's draw it with the specific molecules. Now, formic acid is not an IUPAC name, it's a common name for the simplest carboxylic acid you could have. It's the one that red ants inject under your skin. If you have a carbon double bonded to oxygen, single bonded to OH, that is a carboxylic acid. And actually, let me draw this H just so something will be clear in a second. I'll draw that in a different color. Now, if the other carbon can only have 4 bonds, 3 are already drawn. So if the other one is bonded to another hydrogen, that's the smallest and simplest carboxylic acid you could possibly have. That's formic acid, what they give us here. They tell us that we're reacting this with sodium hydroxide, NaOH. And let me also put this in a different color, so NaOH. That's our base. And we're going to get a salt and water. Now, the H from the carboxylic acid, so this H right here, oops. Let me try one more time. That H, okay. Well, that H and the OH from NaOH come together to form HOH, which is really H2O. That's where the water is coming from. So that is one of your products. Let me draw these back in. So the H came from here, the OH came from there. And what was left, notice that's the H, C double bond O, O, and the Na make the salt. Now, sodium is a metal, and the rest of this is made of nonmetals, and so that's our ionic compound, that's our salt. So this whole thing is the reaction between formic acid on the far left with sodium hydroxide, NaOH, to give you a salt and water. Now that same reaction is just going to be written over again. The only difference is we're going to have a different carbon chain to the left of the carbon in the carboxylic acid here. Otherwise, this will be exactly the same. So first, let's draw our acid. And first, we know that we're going to have an acid plus a base, giving us a salt and water. Okay, so let's draw the acid we're dealing with. It's 3-chloropropanoic acid. Now, the backbone here is propanoic acid. The prefix is prop, so we know we're going to be dealing with 3 carbons. So that's 1, 2, 3. The infix is AN, so we know that there needs to be single bonds between each of those carbons. And the suffix is oic acid, so that means we're going to have that carboxylic acid on one of the ends. So that's propanoic acid. If I were to number this, you have to start numbering it so that it gives the carboxylic acid the number 1. So this is going to be 1, then 2, then 3. If you see in this name, the branch says it's on 3 and it's chloro. So that's going to be a chlorine coming off of carbon number 3. So that is 3-chloropropanoic acid. Now that we've done that, oh, and yeah, the suffix was the carboxylic acid there, that was down here, this oic acid. So now that we've done that, let me get rid of this table so to make some more room. So that carboxylic acid is going to combine with the base, and the base they're giving us is sodium hydroxide. So sodium, and then hydroxide. So that's our base, and let me also, this H. Okay, so we have an acid plus a base, and it's going to give us a salt and water. Well, the salt is going to be everything in black. So we have that Cl coming down, then 1, 2, 3, carboxylic acid with the O, and then the H is going to be replaced by the Na, and finally you'll have HOH, in other words, H2O, which is water. So I'll write that as H2O. And that would be it. So this is our acid plus our base, giving us a salt, which is just any ionic compound. You have a metal and nonmetals, and water. And so that's the balanced equation for the reaction of this carboxylic acid, 3-chloropropanoic acid, with sodium hydroxide, this one right here. How about benzoic acid? And benzoic acid is a derivative of benzene. So that name you wouldn't actually be able to get from this table over here. You would just have to have memorized benzoic acid is a benzene ring. That's a 6-membered ring with alternating double and single bonds, and then a carboxylic acid coming off of it. So that's a carbon right there where the dot is, double bonded to oxygen, single bonded to OH. That's benzoic acid. I'm going to write again the acidic H, the H that gets given away, that makes this an acid, in gray. So that's our acid, and then it's going to get combined with our base, and they give us the base, it's sodium hydroxide. So sodium hydroxide, and that's going to give us a salt and water. Now the salt is going to be everything in black. The sodium will replace the hydrogen. So you have benzoic acid here, but without the hydrogen, it gave that away because it's an acid, and sodium is going to take its place. That's the salt plus water. And so water is, if you take the H and the other OH together, the H from benzoic acid, the OH from sodium hydroxide, you get HOH, which is H2O. And that would be the balanced equation for the neutralization reaction between benzoic acid and sodium hydroxide. Incidentally, this molecule that you get in the product is sodium benzoate. If you ever look in the ingredients for, say, like guacamole or also salsa, a lot of things that could easily go bad, they put sodium benzoate in as a preservative, and that's what it looks like.